Hello and welcome, everyone. Thanks for joining as we continue to come in. My name is Martez Reed. We're going to walk through workload identity for VMware vSphere. So, as I mentioned, I am Martez Reed, Director of Technical Marketing with Morpheus Data. I can be found in a number of different places, LinkedIn, GitHub, as well as Twitter. So, let's get right into this session. So, one of the challenges that organizations face is identity. So, we're starting to see a number of different technologies spring up as it relates to identity. The one we're most likely familiar with is the human identity. So that typically involves ways in which a human being can authenticate to a system, whether that is utilizing something that they know, something that they have, or something that they are. Commonly things we talked about when we talk about factors of authentication. So usernames, passwords, MFA codes, biometrics are things that are commonly utilized to be able to authenticate humans to systems in an IT environment. But what about machines? Traditionally, with machines in terms of identity, we've utilized many of the same methods to be able to facilitate that. It has its own inherent challenges with it, similar to as we see with human beings. So when we start talking about things like the expectation that a human being should rotate their password every 90 days, we're going to do similar challenges when we start talking about things like service accounts being utilized for systems to authenticate to other systems. And so there's the need to be able to rotate those passwords on a frequent basis. Certainly there's been a number of solutions and capabilities that have popped up to be able to address that issue and address that challenge, but still becomes very much a challenge. Certainly in addition to usernames and passwords, things like X509 certificates have been utilized to enable authentication from one system to another system, or things like domain-based authentication or identity, in which essentially there's a level of trust given to a given platform. And so what this actually enables is the ability for one system to be trusted by another system through what's effectively a transitive proxy in terms of authentication or identity. And so what I mean by that is a scenario where I trust someone and another person trusts me. And essentially I vouch for the first person. So then there's the transitive trust in my reference for me vouching for someone. Similar mechanisms are utilized as it relates to identity for systems. So one of the things that many of us are now familiar with as it relates to the public cloud is the ability to be able to streamline that identity process for workloads running in a public cloud to services. In this example, we have, let's say, a virtual machine running in Azure to be able to authenticate to a service that has been exposed. In this case, blob storage. It could be any other number of the other services offered or provided by the cloud provider. But what this allows us to do is simplify that identity process. So one of the things we don't have to do is there's no service account or username and password that we specify in order for the virtual machine to be able to authenticate to the third party, or in this case, the service, which is the blob storage. And so how this is actually facilitated is through that similar transitive trust capability that we talked about, in which Azure has an IAM, or Identity and Access Management System, that is providing information to the virtual machine that can be utilized to authenticate its identity to the service, which is blob storage, to be able to enable it to access it without us specifying a username or a password, or having to worry about rotating those credentials on a frequent basis. In many ways, that's done automatically for us without having to worry about that. So some of the aspects I talked about, that the key thing in that equation is what's known as the Azure Instance Metadata Service. So what this is a system that has been created by the cloud provider. Azure has it, AWS has it. Most of the cloud providers have a mechanism by which a virtual machine or instance that is running in their cloud can access services in the same cloud utilizing an identity that we don't explicitly define all the details of. So once again, we're not passing a username or a password to the virtual machine in order to be able to access object storage or a managed database or insert additional managed services. It's done and facilitated essentially under the covers utilizing this mechanism. And so one of the things to specifically call out is solutions like the CLI and SDKs have been built out to talk to these API endpoints that are exposed via the instance metadata service. And so what that gives us is that solution in which if I were to run a command from that instance or that virtual machine utilizing the Azure CLI or Azure SDK, I can just simply authenticate utilizing the machine's identity. And so under the covers, what's actually happening is what we see here from the Azure Instance Metadata Service, handling all the heavy lifting for us. And so what it's actually exposed over is 169.254.169.254, which is an IP address that is accessible from inside of the virtual machine or instance, in which the SDK, the CLI, as well as human beings at the command line can access or interface with. So we're talking about identity for VMware vSphere workloads. And so that's been the precursor to ways in which we can mimic or emulate this same sort of functionality in a VMware vSphere environment. And so that's what gets us back to this scenario of, let's say I wanted to integrate my on-prem virtual machine with Azure Blob Storage or AWS S3 to be able to enable it to push backups or push some data into the object storage or interact or interface with a managed database or insert additional cloud service that I might want my VM-based workload to be able to access. And so the challenge we have is VMware doesn't have an instance metadata service that we can expose within the virtual machine that can be utilized to actually access that identity information. So as I mentioned, a number of solutions are available to provide some of that functionality. This is still, in many ways, very much the early days of what we talk about, that workload identity. We're starting to see it more and more from a federated identity standpoint, even scenarios in which we see cloud providers providing a mechanism to be able to connect to other cloud providers, where I might want to connect from a Azure virtual machine to a service that's running in AWS and be able to facilitate that in a way that avoids me statically coding or hard coding credentials for that workload. So one of the projects or one of the solutions that provides some of that framework capability is a project called SPIFEE. And so SPIFEE is really a framework that provides an identity mechanism by which we can start to authenticate workloads to other workloads or to services. And so what it leverages under the covers is X509 certificates to facilitate this capability. It's actually utilized by Istio, which is a service mesh, HashiCorp Console, another service mesh, Kuma, which is finally another service mesh, and then it's actually used by a project called Spire, which is part of the same body of working group that is actually an implementation of SPIFEE. So what's being leveraged is X509 certificates, one of the things that we talked about with workload identity as a means to move away from the usernames and passwords, but leveraging something that the system has available to it. And so Spire is touted as a production-ready open source implementation of the SPIFEE framework. So it includes a number of different components that provide the functionality to be able to enable workload identity from one machine to another. So it includes a server agent-based architecture in which the server helps facilitate and deploy the certificates that are utilized for identity and agents that run on the system to help actually facilitate that transaction with the server. A number of things it also uses is workload as well as node attestation. So what that actually is a mechanism by which we can confirm or validate what's actually being utilized from a deployment standpoint. So it provides a number of capabilities. One of the other ones is vAuth. So full disclaimer, it's actually a project I have created, but really what it provides is an example in which it can be utilized to integrate with HashiCorp Vault, a common secrets management platform, to dynamically generate credentials on behalf of the workload. And so at its core, from a diagram perspective, certainly there's a lot to take in here, but really at its core, what it's going to provide is, and what it provides is a mechanism by which I can utilize HashiCorp Vault to provide identity information to the virtual machine running on VMware vSphere and treat it as a trusted platform. So that gets back to that transitive identity or authentication that we talked about, in which I'm going to trust the VMware vSphere platform and what's been deployed into it. And so now I want HashiCorp Vault to trust it. And so essentially vAuth is providing that transitive trust. So it's vouching for my VMware vSphere VMs. And so what's being leveraged is the guest information. For those that are familiar with vApps and OVAs and OVFs, that's commonly what's used from a configuration standpoint. So we're leveraging that same functionality to be able to inject identity information for the VM that now becomes available to the virtual machine. And so that also provides a mechanism by which we could run, let's say, an example piece of software where we integrate with that information to authenticate to HashiCorp Vault to expose Azure credentials or AWS credentials. And from a HashiCorp Vault standpoint, they support the ability to be able to dynamically generate those and those be short-lived. So now we're getting into a paradigm or mechanism that's very similar to what we have from a public cloud standpoint on-prem. So in this case, leveraging HashiCorp Vault as a broker, it could be any other platform that facilitates this capability. I know a number of the solutions utilize things like OIDC as the means by which it's going to facilitate the federation of identity as well. So definitely a number of possibilities and ways in which VMware vSphere can be integrated into whether it's public cloud or even what we're starting to see more and more as an industry is a lot of those similar services being available on-prem, whether it's something like MinIO or a Cloudian from an object storage standpoint, various capabilities that we might want to authenticate to from an identity standpoint. Thank everyone for coming out and joining the talk. Definitely feel free to grab me for any questions you might have. Appreciate the time.